DNA is the genetic code that builds the millions of cells that form the human body. Within our DNA are thousands of genes that determine the color of our hair, our height, and even the number of freckles on our face. More importantly, mutations in some of these genes can lead to chronic and life-threatening diseases, illnesses, and disabilities. But what if we could eliminate these mutations? We now have the ability to alter genes within the DNA of fertilized eggs and even in living organisms. The alteration of the genetic makeup of fertilized eggs has developed offsprings coined as designer babies. According to obstetrics, gynecology, and reproductive medicine, designer babies are babies originated from embryos created by in vitro fertilization and selected because of the presence or absence of particular genes. The ability to evaluate, alter, and select the genes of fertilized eggs and living organisms provides families with several opportunities to increase the quality and longevity of the lives of their offspring. But despite all the benefits, the process is now raising so many moral problems. In this video, I would like to explain the term designer babies and the technological advances that have enabled the development of genetic alteration. After providing you with a better understanding of designer babies, I would like to describe the positive and negative benefits associated with the powerful ability to alter, select, and delete genes. Through the evolution of technology, we are now capable of altering the genes of fertilized eggs. There are various methods and systems that have the capabilities to scan DNA for mutations, fix mutations in genes, and even turn off the expression of specific genes. With these capabilities, the family can now not only evaluate the genetic makeup of their embryos, but they can even turn off or alter mutations in the genes of fertilized eggs. The power of this type of technology creates the potential to create healthier offspring. With this, the power of technology also provides people with the opportunity to select hair color, skin color, and even IQ score that they would want for their child. Because of this, the uses of this technology have been highly debated in terms of morality and fairness. I'll go into both sides of this argument in the later part of this video. The event that started this widely debated technology began almost 20 years ago. Since the original designer babies, several advances have been made that give scientists even greater powers in the modification and alteration of genes. In 2000, Adam Nash was born into the world as the first designer baby. According to an article released by The Guardian, Adam Nash's genes were genetically screened so that the test tube baby could become a donor for his 6-year-old sister who suffers from a rare and fatal genetic disease known as Fanconi's anemia. Fanconi's anemia is a rare disease that causes bone marrow failure. To ensure that Adam would be a viable candidate to his sister, Adam's parents used a pre-implantation process where they selected the embryo they wanted from a group of 15 embryos, and the egg that was implanted was free of disease. Through the pre-implantation process, the Nash family was able to extend the life for their 6-year-old daughter while also bringing another child into the world with the knowledge that it would not suffer. Since the first genetic screening of designer babies, several other technological advances have been made. Today, a protein known as Cas9 is part of the CRISPR-Cas9 system that can even edit genes in living cells and organisms. On November 15th of 2017, this CRISPR-Cas9 system was first introduced on 44-year-old Brian Madu. Brian suffered from a metabolic disorder known as Hunter syndrome. Hunter syndrome is caused by a mutation in a gene that produces an enzyme that plays a crucial role in the breakdown of sugars. Without this enzyme, a case report on Hunter syndrome explains that a person suffers from issues associated with the nervous, cardiovascular, respiratory, and musculoskeletal systems, along with numerous oral manifestations. In Brian's case, the CRISPR-Cas9 was used to locate and repair the specific mutated genes in several of Brian's cells. Within the methods of molecular biology, they define Cas9 as an RNA-guided nuclease that is capable of binding to a target DNA. Its specificity is defined by sequences encoded within the RNA component. To explain the Cas9 protein in simpler terms, let's look at this diagram. This process would allow the Cas9 protein to be programmed with an RNA able to cut the specific mutated genes. The technology to alter mutated genes in this way opens up endless possibilities for the human race and our genetic makeup. With the ability to easily alter the genes within individuals, at what point do we stop? At what point does altering the genes of an individual become unmoral or provide individuals with unfair advantage? At this point, I would now like to address some of the arguments that are claiming that this type of technology could potentially be unmoral and unfair. Many people view gene alteration as an unjust method that oversteps the boundary of organisms flowering, growing, and entering the world naturally with the genes they've been given. Some people believe that altering the genes we were naturally given could decrease genetic diversity across the human species. If gene selection were to become so advanced that parents could individually pick every gene that their child acquires, wouldn't most parents be picking genes that would make their children the smartest, the tallest, or the strongest? By doing this, we would be eliminating so many genes from our gene pool that if we were for some reason to encounter an event that caused natural selection, the entire human species would be wiped out. As this process would continue, the children who are more genetically modified to be stronger, faster, and smarter are more likely to become more successful. On the other hand, children born into low socioeconomic standing have less chances to become successful. As a result, the socioeconomic gap between the upper and lower class would continue to grow. Gene alteration could also change the profile of our species. If you were having a child and you could decide whether you wanted them to be a male or female, or to have light skin or dark skin, would you give your children genes that would attach stereotypes or disadvantage to them? I would assume that most parents would not. Therefore, our species as a whole would become more male-dominated with less diversity in terms of skin color and other characteristics associated with negative stereotyping. If families used in vitro fertilization to select the embryos that were male or had lighter skin, what would that mean for the rest of them that were not selected? During the pre-implantation and in vitro fertilization process, only one or maybe a select few would be chosen and actually implanted into the uterus. Given that the other embryos have been fertilized, some could argue that the embryo is in fact a living organism and that by not choosing life for this embryo is a form of abortion. This question is raised in an article from Reproductive Biomedicine Online, asking, is it morally impermissible to create and to destroy a perfectly healthy human embryo? From the in vitro fertilization and the CRISPR-Cas9 processes that have already occurred, lives have been saved, also impacting the lives of so many people around. The possibilities of this technology are so powerful and can be used positively to impact the human race in so many ways, but it also holds the power to negatively impact the human race. Because of this, the morality and fairness in these types of technology have largely debated over the years, and most likely will continue to be discussed. I hope that scientists, families, and the entire human race can find ways to use it for its abilities to save and better lives.